Hey, welcome back to your favorite trigonometry class. Good to see you today. We got the law of sines. Here's our objectives for that. The law of sines is going to be used to solve oblique triangles, right? So no more right triangles. We've got oblique triangles. And the cases in which the law of sines will apply will be case 1 and 2. So where you have angle side angle or side angle angle or side angle. These are the two that we'll do. In fact, I got a picture right here. So case 1 and case 2 situations. Notice we have angle side angle. So the side between them is given, or angle angle and a side. Or the ambiguous case, which is called angle or side angle. But if you read that backwards, bad word, right? Angles. That's how I remember it, is because it's kind of backward. It's the ambiguous case. We'll talk more about that. But these are for law of sines. These other two will be for the law of cosines. Okay, and again, these are for oblique triangles. So here's the old law of sines. You'll also see it written in some textbooks in the equivalent form here. I think it's important to see the proof of the law of sines. So if we start with a triangle here, this is where this comes from here. A, angle B, angle C, little a, side opposite, little b, little c. We've got the height of the triangle here, the altitude goes straight down, creates that 90 degree. So what I'm going to do first, number one, is I'm going to use my right triangle trig knowledge, and I'm going to say, you know what, I know the sine of this angle C is the opposite, right? We've got a right triangle over here. Right here, I'm looking at this triangle. Sine of C would be h, the opposite side, over the hypotenuse A. So in other words, if I multiply both sides by A, my h is A times the sine of C. And I also know, if I look at this right triangle over here, the sine of A is the opposite side h over the hypotenuse C. Solve for h, so multiply both sides by c, so I got c times the sine of A. Now, so h equals, then these heights are the same, right? This is the same h here. So if h equals h, by substitution, A sine of C equals C times the sine of A. Right, and then we just get in the form that we like here. Let me divide both sides by sine A. So I have A sine C over sine A equals C, and then I'm going to divide by sine C, both sides. So I have A over sine A equals C over sine C. Right? You could do a sort of similar process with B, but we showed that these two, right, those two are the same, right? Also for B over sine B. So that's where the law of sines comes from. Now let's do it for a situation where we have, let me get my lovely blue here, where we have angle side. We have an angle side situation. So let's draw this. We have A, we got B, we got C. Our A is 45 degrees. Our B is 55 degrees. Side opposite A is 5. Notice we have angle, and then a side, right? Angle, side. So we're going to use the law of sines here. And the first thing, though, that I'm going to do is I'm going to say, well, I remember that all three angles of a triangle add up to 180 degrees. So 45 plus 55 plus this angle C. So I'm going to solve for angle C first. So this angle C was set at 80 degrees there. Angle C ends up being 80 degrees. And then number two, I'm going to use my law of sines. I'm going to use it with, and I should write in here 80 degrees now, right? I know I have little a, I have the angle A, I was given angle B, so I'm going to use these two right here. So I have 5 over the sine of 45 degrees equals B, I'm solving for B, over the sine of 55 degrees. All right, now we've got a proportion here, so we can cross multiply this. So B times sine of 45 degrees equals 5 times sine of 55 degrees. Divide both sides by the sine of 45 degrees. And your B ends up being, punch this in, 5.79228, so about 5.79. And then thirdly, I'm going to say 5a over sine of a equals, make sure your calculator's in degrees, by the way, equals c over sine of capital C, which we know is 80 degrees. Angle C is 80 degrees. Go ahead and similar process. C times the sine 45 degrees equals 5 times the sine 80 degrees divided by sine 45. And C ends up being 6.96364, so it's about 6.96. And we've got everything. Okay. All right, let's do another one. Now, this time we've got an angle side angle situation. So we've got this acute angle A, pretty acute angle B. So I'm going to draw this oblique triangle like this here, try and make it a little more accurate. So 20 degrees, 25 degrees. We got little c. So notice we have angle, we have the side given, and then we have that other angle, angle side angle. So we're getting lost signs here. Number one, we're going to solve for c. So 20 degrees plus 25 degrees plus angle c is 180 degrees. So this angle c ends up being 135 degrees. Number two, I'm going to go c over sine of c, because I just got my 135 degrees right there. So I have both of those. And then I can use, I'll use A, and I have capital A, the 20 degrees, right? So we got 4 over sine 135 degrees equals A over sine of 20 degrees. Cross multiply. Divide both sides by sine of 135. Punch this in. 1.93476, so it's about 1.93. And then number three, we're going to go 4 over sine of 135. So C over sine C equals B over sine B. Solve for B. You get 2.39069. It's about 2.39. Okay. All right. Now, when we have side-side angle, this is what's referred to as the ambiguous case. And that's because we don't know if there's no triangle, if there's one triangle that it could be, or if there's actually a possibility of two different triangles with the given situation or given conditions that they give us. So that's why it's kind of the ambiguous case. So I remember this because I read it backwards, the bad word. You know, if I read that backwards, I'll keep this rated G here. Because I'm like, yeah, that's bad backwards, right? So it's the ambiguous case. It's kind of a mess. And so the situations are you could have two triangles, one triangle, or no triangles, okay? So the first thing that I like to think about is I'm going to determine if A is acute, that's the ones over here. A is the given angle. Given angle A. If it's acute, or if the angle is obtuse. It could be one of those two situations, okay? And we're going to solve for h, and we're going to compare A, B, and H. Now again, notice it's my given angle A, and then in addition, they're also giving you the side length B. Okay, so just note that, because it's not like in this first example, notice they don't give us angle A, so we're going to have to kind of go back and forth to that picture. That's in the diagram, that's the angle A, that 50 degrees that they're giving us. Okay, but let me draw it, and I'm going to keep it with angle C so that you can kind of see this. So this is the given angle they give us, and then again, usually this is angle A in diagram, and then I'm going to call this A because they give us side length A. This is usually B in the diagram. Okay. Alright, so number one, what I'm going to do is I'm going to say, well, I know it's this given angle is 50 degrees. It's acute, okay? So I'm looking at these four situations here, okay? Now I'm going to let me find the height of this triangle here. Whoops. So let me draw H, and I'm going to use right triangle tricks. So number one, the sine of 50 degrees is the opposite over hypotenuse, which is 2. So H equals 2 sine 50 degrees. So H equals 1.532. Okay? Now, notice, let me come back here. A, the side opposite, this was 1. This is 1.532. So the opposite side of the given angle is less than the 1.532. So there's going to be no triangle given. In other words, when I drew this thing, if I would have been able to know this, I would have known there's no way that that can attach right there, because it's shorter than the height of the triangle. Okay, so since 1 is less than 1.532, so 1 is the side length opposite. In terms of the diagram, that's A and H. There's no solution. There's no triangle that's going to work here. Okay. Now, I want to run through this because you should be able to see it if you run through it. Okay. So, like, let's say we went C over sine of C, so 1 over the sine of 50 degrees, and we try to solve that for 2 over sine of A. And we cross multiply this thing, so we got sine of A equals 2 sine 50 degrees. So sine of A, we punch that in, and it's 1.532. Now think about this for a minute. The sine of an angle, is there any angle in which the sine is more than 1.532? And we're like, no, the highest sine value we have is at pi halves, right? Well, and there's other ones obviously that have a sine value of 1. If you think about, sine, the highest we get is 1, right? If we were to graph the sine function. And even if you ran the arc sine on both sides, you're going to get error when you do that on your calculator, right? So there's no angle in which the sine can be greater than 1. So again, no solution. There's no triangle that'll meet these conditions. All right, let's do another one here. Nice thing about this one is they give us angle A, so it actually fits our dang diagram. Okay. All right, so number one, let's go ahead and let's find this h. Let's compare the h to the a and the b. So number one, sine of 60 degrees is h over hypotenuse 3. So multiply 3 both sides. You get 2.598. Okay? So let me go back to the diagram for a minute. So a is not less than h. In other words, because my a was 4, my h was 2.598. Okay, so a is actually greater than h. So it's not this one, right? It's not that one. A is not equal to h. A is greater than h. So then the question is, which one of these situations is it? Is a greater than or equal to b? Is a greater than or equal to b? Well, let's go back to what we were solving. Sure enough, it is. 4 is greater than or equal to 3, right? 4 greater than or equal to 3. A is greater than or equal to b. So we just have one solution. There's only one triangle that this will work for. Okay, so we can go about it, and I'll show you when you're working this thing. You'll probably be able to figure that out as well as you're going along. So let's go law sine. So a over sine a equals b over sine of b. Cross multiply. 4 sine of b equals 3 sine 60 degrees. Divide both sides by 4 by 4. So sine of b equals 0.649519. So angle B is the arc sine of this. And by the way, think about this for a minute. You have the sine of B, this angle, B, sine is 0.649519. There's two spots where this could happen. Two angles, right? There's this angle, and then there's that angle as well. So this one I'm going to call B1, the other one I'll call B2. So angle B1 is the arc sine of 0.649519. Make sure your calculator's in degrees when you do this. And that spits out 40.5 degrees. Okay. So that's this angle right here, 40.5 degrees. So the other one, because this is the same amount, that's 40.5. So it would be 180 minus that. So angle B2, again, that would be this one. That'd be B2. Angle B2 would be 180 degrees minus 40.5 degrees. So that'd be 139.5 degrees. Now that can't work because think about it. If angle B is an obtuse angle, so it's actually right here, right? If it's an obtuse angle, then 139 plus 60 plus whatever up here, right, has to be 180 degrees. There's no way because 60 plus 130, that's 199.5 degrees already without even the third angle. So this can't happen. So we only have one triangle this will work for. Okay, so angle B, so it's this one, that's 40.5 degrees. That's the only option we have. So let's continue on then with this. If angle A is 60 degrees, angle B then is 40.5 degrees. Again, make sure your calculator's in degrees on this stuff. And then we've got angle C. All these add up to 180 degrees. So angle C must be, and that's angle C up there, 79.5 degrees. Okay. Let me stop here and I'll do another